A KD tree, or k-dimensional tree, is a k-dimensional extension of a binary search tree. So what does this mean? Well, first of all, it means that a one-dimensional tree, so a KD tree with k equals 1, is exactly a binary search tree. But basically, a KD tree is a binary tree where for every level of the tree, we're only looking at one dimension of the points. So let's take a simple example where we have a 2D set of points. Let's say the first point that we insert is the point 21, 42. So maybe in yellow, I'll put the points that I'm adding in order. So 21, 42. So I'm inserting this into an empty KD tree. So what this would do is it would create a root node, just like with a binary search tree, and insert that new node into the root. So this point, x is 21, y is 42. This point is the root of my KD tree. Now let's say I add another point, 10, 100. So a KD tree, we go level by level, alternating which dimension we're looking at. And at a given level for that corresponding dimension, we act just like a binary search tree. So here, I'm inserting 10, 100, so the x-coordinate is 10, the y-coordinate is 100. I start at the root, this is level 0. Let me actually maybe draw some lines dividing my tree space by dimension. So when I'm in this level, I'm going to be checking x-coordinates. So binary search tree operations, like binary search tree comparisons, precisely as they are in binary search tree, but with respect to the x-coordinates. This level with respect to y-coordinates, this level with respect to x-coordinates, this level with respect to y-coordinates, so on and so forth. So I'm adding the node 10, 100. So I start at the root. There's a node here, so I'm going to compare our x-coordinates. The x-coordinate is 21. I'm 10. I'm less than 21. So I should be to the left of this node. There's nothing there. There's no left child. So I will add this as a new left child of the root. Let's say the next node that we're adding is maybe, let's say 15, 200. So I start at the root. There's a node here, so I compare our x values. I am 15. The current node is 21, so I should go left. Okay, now I'm on this level. I should be comparing y coordinates. I am 200. The current node is 100, so I completely ignore the x value. I'm only looking at the y coordinate because I'm on the y level. I'm bigger than 100. 200 is bigger than 100, so I would add this as the right child of that node. So this is 15, 200. What if I were to insert the node, let's say 20, 50. So I start at the root. I'm comparing x coordinates on this level. 20 is less than 21. I should traverse left. Okay, on this level, I'm comparing y coordinates. 50 is less than 100. I should traverse left. There's no node there, so I will insert this as the left child. 20, 50. So 20 was less than 21, so I went left. 50 is less than 100, so I went left. I inserted it here. Let's do one last example. Let's say we're going to insert 20, let's say 20, 300. Let's see what would happen. So 20 is less than, so I'm comparing x coordinates. 20 is less than 21, I go left. 300 is greater than 100, I go right. I'm comparing x coordinates now. 20 is greater than 15, so I would go right. 20, 300. So here I was comparing 20 with 15. 20 is greater than 15, so I went right. So in general, I'm doing things precisely like a binary search tree with respect to whatever the current level's coordinate is. So here, I'm comparing like a binary search tree with respect to x coordinates, here with respect to y coordinates, here with respect to x coordinates, here with respect to y coordinates. Let's try another example of inserting elements into a KD tree, but this time let's use three-dimensional values. So our points are now three-dimensional points, and our layers of our KD tree will alternate x, y, z, etc., etc., etc. So I've laid out the outline of my different layers, and I have my points here. Let's insert them. So the first point is the point 10, 0, 100. My KD tree is empty, so this just automatically gets inserted as the root. So this point is done. The next point is 5, 10, 15. So I start at the root, and I'm comparing x coordinates. 5 is less than 10. Again, I completely ignore the other coordinates. 5 is less than 10. Therefore, I go left. There's no left child, so I will insert this as the left child of the root. There we go. Second one is done. The third point is 7, 7, 7. So again, I start at the root. 7 is less than 10. Again, I don't even care about the other dimensions, just looking at dimension x right now. 7 is less than 10, so I go left. 7 is less than 10. So again, I'm only looking at y coordinates now. So this 7 is less than this 10, so I go left again. There's nothing there, so I will add this as the left child. That one's done. Now 9, 0, 0. So 9 is less than 10, so I go left. 0 is less than 10, so I'm comparing y coordinates. I go left again. Z coordinates now. 0 is less than 7, so now I would go left. For fun, let's add one more element maybe. Let's try adding maybe, let's try adding 11, 10, 9. So 11, 10, 9, I start at the root. My x coordinate is 11. This is greater than 10, so I would add it here. What about, let's say, 11, maybe, let's say 11, 0, 0. So I would start at the root. 11 is greater than 10. I go right. 0 is less than 10. Again, I'm comparing y coordinates here. So it would be the left child of this node. So same exact thing. Again, every layer, I'm doing the exact same comparison as I was doing with a binary search tree, except the layer I am away from the root dictates which coordinate, which dimension I'm looking at. At the root, I'm looking at dimension x, then I'm looking at dimension y, then dimension z, then dimension x, then dimension y, so on and so forth. It keeps alternating.